All right, ladies and gentlemen, I'm going to go over that formative you guys took yesterday real quick. I am going to go pretty quickly through the formative. If you guys have questions, just let me know as I'm going through. Stop me as we continue working through it. And if you have no questions, you don't need to stop me. But anytime you have a question, I'll ask every once in a while, but make sure you're stopping me if you don't understand something. So if we're looking at this first one, we have a covalent compound because it is two nonmetals. So it's going to be covalent. And we're looking at carbon and hydrogen. So if it's covalent, we have to remember that we do include prefixes for both our elements. And so that means we have 4. So it's going to be tetracarbon, as we just enter in the first element's name. And then it's going to be hepta. And then hydrogen gets its ending changed to IDE. So it's going to be heptahydride. The next one is also a covalent compound because we have two nonmetals again. And so for this one, we have nitrogen, and nitrogen does not get a prefix because there's only one of them. So it's just going to be nitrogen. And then we have fluorine, which its ending is changed to IDE, so fluoride. And then the prefix in front of fluorine is going to be tri, so it's going to be trifluoride. The next one, if we're looking at silver nitride, the silver is a metal, which means we have an ionic compound. When we're figuring this one out, we know that silver has a +1 charge because if we check our ion sheet, because silver is a transition metal, it has a +1 charge. Nitride is nitrogen with a -3 charge, which means we would need 3 silver with their +1 charge, so our charges can add up to 0. So if our charges add up to 0, we need Ag3N. When we draw this one out, we have to do two things. First, we need to draw out all of our compounds, or all of our elements in the compound with their valence electrons. So because each silver is losing 1 valence electron, it has 1 valence electron to lose, and then nitrogen has 3 to gain. So we'll show that transfer of electrons. And then we do also need to draw them out in ion form. So you can draw them as 3 silvers with their +1 charge. Or you can draw the right 3 times that silver with the +1 charge, and then our brackets with our nitrogen with all 8 valence electrons drawn around it with its -3 charge. I do need to see both of those when drawing your covalent, or sorry, when you're drawing your ionic compounds. The next one is also covalent because we have carbon and hydrogen. The tri tells us there's 3 of them here for carbon, and the nana tells us there are 9 hydrogens. Continuing, we have titanium 4 iodide. Titanium is a metal, which means we have an ionic compound. This Roman numeral 4 tells us that titanium has a +4 charge because it is going to be losing 4 valence electrons. Iodine, we should remember, has a -1 charge because it has 7 valence electrons, only needing to gain 1 to have a full octet. That means if we want our charges to balance out, we would need 4 iodines with their -1 charge to balance out the 1 +4 charge. When we write this formula, then we have titanium 1, iodine 4. When we draw this, we have to draw our valence electrons around each of them. So 1 titanium with 4 valence electrons, and then 4 iodines with 7 valence electrons. It's an ionic compound, which means we are drawing that transfer of electrons. They're not being shared, so we don't draw the circle between the 2 electrons. And then we draw them or write them in ion form. So we have 1 titanium ion with a +4 charge and 4 iodine ions with 8 valence electrons now, giving each iodine a -1 charge. The next one, we have mercury and oxygen. And so mercury is a metal, which means this is ionic again. Now for this one, mercury is a transition metal. So we need to figure out its charge to determine what Roman numeral to put next to our mercury. So in order to do that, we know that oxygen always has a -2 charge. And we know we have 2 mercuries. Those 2 mercuries have to have a total of a +2 charge to add up to make 0 for our total charge or net charge, which means each mercury has a +1 charge. Or we're going to have mercury mercury 1 oxide. When we draw this one out, we have mercury with its 1 valence electron. We have 2 of them. And we have 1 oxygen with 6 valence electrons. And we're going to show that transfer of electrons again. Writing our ion form of 2 mercuries with a +1 charge each. And the 1 oxygen with its 8 valence electrons, giving it a -2 charge. All right, our next one, iodine. Iodine is a nonmetal, so it's going to be a covalent bond. And iodine is a diatomic, which means it is I2, because there needs to be 2 of them for diatomics. The next one is a covalent compound because we have 2 nonmetals, nitrogen and oxygen. The first one is nitrogen, and there are 2 of them, which gives it the prefix di. The second one is oxygen, and there are 7 of them, which gives it the prefix hepta. And then because it's oxygen, we actually lose that A. So it's just going to be heptoxide. If you include the A, it's not going to be marked against you. It's just something because you don't ever have an A and an O next to each other in these names, or 2 O's next to each other. The next one is lithium iodate, and lithium is a metal, which makes this an ionic compound. Lithium is Li with its +1 charge because it will lose 1 valence electron. Iodate is not the same as iodide or iodine. That ATE tells us we're looking on our polyatomic ion sheet. If it ends in ATE or ITE, we have to check that ion sheet again. And this time we have iO3, and it has a -1 charge. So our charges add up to 0. So we write LiIO3. The next one, we have chromium and oxygen. Chromium is a metal, which makes this ionic. And chromium is also a transition metal, so we have to figure out its charge. So we have oxygen with a -2 charge. And since we have one chromium, it has to have a +2 charge. So we have chromium 2 oxide. The next one, we have carbon and hydrogen, which makes this covalent. There is a di in front of carbon, which means 2 carbons, and tetra in front of hydrogen or hydride, which makes that have 4 hydrogens. The last name we have to come up with is for aluminum and sulfur, which makes this an ionic compound. Aluminum is not a transition metal, so we just need to write aluminum. And then sulfur gets its ending changed to sulfide. Drawing this one out, because it's ionic, we have to show the transfer of electrons. So we draw our Lewis dot structures for all 5 of the elements, giving 3 valence electrons to each aluminum and 6 valence electrons to each sulfur. And showing the transfer from aluminum to sulfur, 2 valence electrons to each sulfur. And then showing your ion form. So there's 2 aluminums with their +3 charge and 3 sulfurs with 8 valence electrons, giving it a -2 charge. Are there any questions on that? I know I went through that rather quickly. Are there any questions on any of the problems from your formative yesterday? All right, then, ladies and gentlemen, you have a review for your summative for tomorrow. So you guys have your summative on bonds. On that summative, you need to remember how to name ionic bonds, name covalent bonds. You need to be able to name, write the formula for ionic bonds, write the formula for covalent bonds, draw ionic bonds, draw covalent bonds, and identify polarity between the elements. So you have multiple choice questions up at the top, and then you have drawing questions where you need to identify the name or formula, identify the polarity. You need to make sure you show your work in that polarity. It does count for points. If you don't show your work, you will lose points. So showing all your work. And then you need to draw the Lewis dot structure, showing the electrons either being transferred or shared and what that looks like in the end. So either the ion form or drawing the bonds at the end. There are 2 problems where you do not need to draw them, and that is going to be number 12, do not need to draw. And number 15. That is because they are polyatomic ions. So they come from your ion sheet, and they are going to make it a lot more difficult to draw just because they have ionic parts and covalent parts, and we just don't need to worry about that right now. If you want to know how to draw it, the answer key does show them drawn, but you do not have to worry about that at all for this. Are there any questions on anything we've talked about today? All right, then if I don't see you tomorrow, have a wonderful Thanksgiving break. Make sure you guys are working on that summative tomorrow. If you guys have questions on the summative, don't just sit there and hope for the best, but actually join the Zoom meeting and ask your questions. So that way you don't fail, or don't just stop doing the test and give up because you don't know how to do something. Make sure you join the Zoom meeting, the open Zoom meeting, and ask your questions.